Hello guys, so today we will be discussing like minimum spanning tree problem. So let's try to make a simple diagram first. Suppose we have few stations, so these are the stations, okay, and there are few distance between these stations. Let's name the station. Suppose this is station A, B, C and D. Fine. So we have distance like 5 unit from A to D, 7 unit from D to C, 8 unit from C to B, and B to A it's 9 unit. But you can directly go from A to C and the distance is 10 unit. Now what exactly we need to do over here? We need to make an arrangement. We need to make an arrangement. Suppose this station has some connectivity. These are the paths. So A to D, this is the path of this is the path we can use, one can use from to reach station D from A. Now if anyone wants to use C from A, he can either go ADC, he can either take AC, he can either take AB, BC, this path. So the question is that we need to make an arrangement so that we minimize this walk or through this path and make all stations connected. Okay, all station needs to be connected. So what is the what should be the minimum space we can use, so that I mean minimum how many what is the way so that every station A, D, C, B gets connected. So if you just think properly, if you can make something like this, suppose this is our A, this is our D, this is our C, this is our B. So you can go from A to B but via this path. You can, although you have not make them connected, you can think this is and where you can go A to D via this path, which is having 5 unit. You can go D to C, which is having 7 unit. You can go C to B, which is having 8 unit. So what is the amount you have covered through this arrangement? So if it is an arrangement, through this arrangement, how many distance you have covered and make every stations get connected? So that is nothing but 5 plus 7 plus 8, that is 20 unit. If you take any other arrangement and this value is not going to be 20, it is going to be more than 20. This is the minimum thing. So this is an arrangement which we can probably generate with the help of our knowledge. Now it is basically a spanning tree. Now we will come what that spanning tree is, but before that let's understand that from the graph perspective, it is first of all an weighted graph, and a weighted graph, and this is also connected weighted graph, right? This is basically a connected weighted graph. So let me write it first. So this is connected and this is weighted. But there is another property which we are probably missing over here, that this is undirected as well, undirected curve. So this algorithm which we are talking right, which we will be talking right now, that is Prim's algorithm, will be used for this type of graph, or graph which is having this type of properties. It should be connected, it should be weighted, and it should be undirected. Okay, now let's try to understand the main point, that is what is spanning tree. Suppose we have given a graph which is having this property. Okay, so what is the spanning tree we can uh, we can say that, or what, how we get the spanning tree, how we got get the concept of spanning tree. So let's try to understand spanning tree. So suppose we have given this diagram, everything is closed, everything is connected, and there are some weights. So what is going to be the, spanning tree for this graph? So spanning tree, if you have v edges, right, in spanning tree you will have v minus 1 edges. Okay, and it should not, first of all, this is going to happen and should not have any cycle, should not have any cycle. So if it is the case, then it could be like this, or it could, we can either we can drop this one or we can drop this one and anything else, right? And in that case we have v edges, 4 edges, 4 vertices. So sorry, 4 edges, 3 vertices. So it is satisfying 1 and 2 both. So this is going to be a spanning tree. Now if we go back to another diagram, suppose this is the diagram where we are making everything closed, say for example this one. So what is going to be the probable spanning tree for this? So we can do v minus 1, we can drop this one, right? We can drop this one, we can drop this one as well. So this is going to be a spanning tree. So in that case 1 2 3 4 5, and you have 1 2 3 4, right? So that is going to be, so both things are getting, it is not a cycle shaped, as well as it is having v minus 1 edges. So that is basically satisfying both two things, and that is basically a spanning tree. Now suppose a problem statement has given like this, you have a, you have another node called c, this is also termed as vertices, I'm terming as node, this is, you are having b, and you got a connection with d, and d got connection with e, suppose this is the case, and you have a be connection. Suppose we are giving some weights over here, this is an weighted graph, and this is basically connected in nature. So 3 5 and 6 and 10. Okay, so the question is, if we consider this problem, we might have a lot of spanning trees, right? There could be a lot of combinations, right? So for an example, one possible, or you can say like possible spanning tree, ST I'm saying. So like this one, A, B, D, E, and this one, this. So you just drop this one, 1 2 3 4, you got 5 altogether. So this is a spanning tree. So similarly you can drop this one. So there are a lot of options, like what I'm trying to say like this, right? So you can have this one, something like that, 1 2 3 4, this is also a spanning tree. So you have a lot of options. Now what exactly Prim's algorithm demand from us? Prim's algorithm says you have a lot of options, so if you just calculate total weight, right, so it is going to be having some weight x, it is going to be having some weight y, there would be another option which is having which might be having weight like z. So we need to find out the minimum weight among all possible MST. Okay, so that is the demand of this algorithm. So first of all, like what should be like the the approach. So if we just want to know the approach, we can take a simple example and we can establish our thought process. Suppose we have a very simple structure like this, and we want to operate on that. So first of all, we have a few nodes like A, and here it is, say for example B, here it is C, and here it is D. Now let's make a connection and make it well connected and give some values out of it. Say for example 5 unit, 15 is the weight, it's 20 is the weight, it's 10 is the weight, it's like 8 is the weight. Okay, So what this algorithm says on a very high level, we are not going to, in this video, we are not going to cover the exact pseudocode, but from the very high level, this algorithm actually prepares two sets, okay, two sets. So first set, it describes like who will be the part of the MST, who will be in MST. MST means who are the nodes or vertices will be responsible to create the minimum spanning tree. There will be another set which is not being considered right now, so not yet considered, you can say, but they are on the queue. They are on the queue. We will take and consider them if they are really applicable. So by the time of the algorithm runs. So the question is, if we consider like this is basically a weighted curve, this is basically a connected graph, this is basically a graph which is undirected. So on top of this we can actually apply the Prim's algorithm, and we can make a dry run on a very high level. So first, the source, if we consider A as a source, so in first case, in the first run, we can consider A. So who is going to be the rest of nodes which has not been considered yet, and they are basically B, C and D, right? B, C and D. These three nodes has not been considered yet. So first set we have considered A. Now whenever we are basically saying A, so this A node, if we see very minutely, this A node actually associated with two edges. One edge basically is from A to B, another edge is basically A to C, and they have their own weights. So if you just make a cart over here, just a cart, so we need to understand that this cart basically having two weights, one is 5, another is 8. So who is basically minimum out of this two? 5 is basically minimum out of this two. So we need to consider that node which brings the minimum weight. So who is the node which brings minimum weight of that edge? That is B. So next iteration we will consider A and B. So who are left? C and D. Fine. So basically in that case we have considered AB. This we our consideration, I mean, after in MST is basically AB. So let's write this A and B. This is phase 1, this is phase 2. So we are drawing for phase 2. Okay, so you have 5. Now what exactly is gonna do? We have to make a cut. So we have AB, right? So this AB has intersection with these three edges, right? Direct intersection, you can say, with these three edges, and these three edges has basically having separate weights, 8, 10 and 12, sorry, 8, 10 and 15. So who is basically having the least out of it? We know that is no one but 8. So basically our consideration in MST is going to be A, B, C. So if we just write this, basically if we just draw this step 3, how will it look like exactly? So A, you got B, you have some weight, that is 5, you have some weight with C, and that is basically 8. So that's basically the something which is happening after step 3, and you are having left D. At step number 4, this is the last step because we are having this thing. So A, B, C, what you are saying, A, B and C. So this is basically like having intersection. These three nodes, if we consider, is having intersection with these two edges. This structure is having intersection with these structures, and which is definitely having edge. If we just consider that edge is basically having 20 and 15, these two numbers. So we need to consider 15. So who is going to be like, where the D will lie? The D will lie at that edge which brings weight value 15. So this is basically the ultimate. So this is 5, this is 8, and this is 15, right? So 28 is the total weightage, right? So this is all about a Prim's algorithm on a high level. We will discuss the pseudocode in the next video. Thank you so much.